welcome to some of the sustainability and green building practices. So for this chapter, we will talk about the sustainability and the green building practices. So in order to have a kind of sustainable either environment operations, we need to write rules and regulation. So this topic is basically to talk about that. There isn't a lot of technical details, but it's more of the regulation. So let's swim on and begin. Yeah. So in the summaries, right, and the requirement under the Code of Environments, right, for sustainability building, is kind of a proof document on the section on efficiency. So the criteria reference will reference to the environment sustainability compliance framework is a simplified streamline, which actually talks about basically two sections. One is the basic or base requirement. The other one is talk about how carbon could be measured. The base requirement indicates like a passive or some active strategy, like a certain amount of power you need to set or certain temperature you need to set. And this has a direct impact on the building code and standardization. So the section on the carbon reduction talks a little bit on the indicator, how low carbon might be the future in the world. So minimally, environment sustainability shall have a level in a way that environment is performed so that it can be provided in a good sustainability environment so that we can have less carbon and in a way carbon reduction. So carbon is kind of measurements based on the combustions of certain fuel. So in Singapore case, it's pretty stable because majority about 90 to coming up to 95% of the time we uses gas, right? Either methane, propane, and then generate electricity still gas turbine and then distributed across the island. Right. Well, of course, we also buy main gases from Indonesia, particularly in Natuna area. But either way, that is the source of the fuel. And of course, recently there is also projects that we're going to pipe some of the clean energy from either Australia to sun, solar, etc. But either way, that this is the way that we look at stuff in terms of carbon reduction. So broadly into three ways. Section one is design, then construction and technology itself. So in summary, like residential, right, base summaries that we have is applicable. There's kind of four means of measurements of reduction. So it's kind of listed down in a table below, and they include some of the measurements and sustainable construction. So for non-commercial building, right, non-residential building, I'm sorry, it lists down some of also there is four criteria of measurements, right, and then in order to have a sustainable construction. So for building, that's only involved in sections of simple structures and building. Solely it is kind of a function that is of a base requirement. So it includes things like underpass, um, open shed, standalone substation, lift, farm as in the solar farms, worker dormitories, the treatment plant, the transport facilities. Yeah, so this is part of the ecosystems is either for the residential or the non-residential development. Right. So part one, RB01 talks a little bit of the envelope of roof thermal transfer. So permissible RETV value is about 22 watts per meter square. So what it means is basically the amount of power or thermal performance on the roof, right, should be about 22 watts per meter square. So amount of permissible, that means the roof ability to accept or to attract um, heat will be approximately 22 watts per meter square. So what is this about 22 watts per meter square? Basically, per meter square, you know, is an area. So 22 watts will mean approximately, let's say you are coming back to the cycling case, right? If you are cycling, like cycling, probably in the 10 to 15 kilometer per hour kind of speed, approximately is about 20 to 30 watts of power. So imagine that sun ray also have power. So basically around 22 watts per meter square of the basically the permissible area in terms of the envelopes of roof thermal transfer. So there's also other criteria like wall to window to wall ratios, right? And also the shade coefficient of glasses. So building envelopment, this must satisfy certain condition so that it can be slightly lower. So there's a different kind of condition and criteria on this. So air conditioning also the same. There's 5 ticks to 3 ticks to or 5 ticks. The higher the tick, the better it is. Right. So a lot of time, approximately about 80% of the total dwelling units and common facilities um, is kind of using either 3 ticks or 5 ticks air conditioning. So that is basically the air conditioning part of it. Lighting systems also have common area. So improvements of maximum lighting is also approximately stated in SS530. Yeah, common uh, what do you call that, mechanical ventilation in the car park, CO sensors to be kind of controlled with your variable speed drive, so that if there's too much CO, carbon monoxide in the car park, the fan can start to kind of kick off. Right. So other base requirement, which we actually talk about that in terms of the building envelope, right? So ITV, which is the building envelope, should not be more than 22 meter, 20 watts per meters per meter square, and then the application of some cool material in the external wall should actually be applied. Um, RB2-2 basically talks about natural ventilation. So buildings should have some 30% of prevailing wind, and then the dwelling design about 25% of the habitatual space should be good for cross ventilation. So that give us some area that air is kind of moving, right? So that is a little bit better in a way that building is not just fixed. So there's area where ventilation can be kind of coming in and out. So effective daylight also has some habitatual space, and then non-habitatual space is where um, you cannot live there, and also we need to provide somehow of a late daylight coverage about 80%. So places like toilet, lift lobby, corridor, right? So those are kind of a non-habitatual space. So going up next is some of the resource efficiency measurements. So like existing building structures with about 50% of the floor or wall should be covered by some additive usage, not with more than 50%, right? So the design of concrete usage index should be about 0.48, and embodied carbon reporting, right? Embodied is basically the amount of carbon generated when you are building up the building should be upfront. I mean, accounted for the emission. So basically, your materials, especially your construction materials like your concrete, steel, glass used in the development. So we also actually will learn a little bit about low carbon concrete. So low carbon concrete is enhanced sustainable building. So it's like concrete of eco-friendly, right? That it is suitable to be kind of have a better lower carbon usage. So that under the CM2 or V type, at least 80% of the super concrete works by volume can be kind of using a low carbon concrete. Yeah. So recycled concrete, right? Sometimes called recycled concrete aggregate, RCA, or sometimes washed copper slag, WCS, from a approved source can meet some of the usage, right? That is about 1.5 GFA gross floor area for recycled concrete aggregate, which means that we actually use some low carbon concrete. Yeah, of course, this requirement are generally kind of a code that simulated some of the design. All right, and then sustainable product, which we have some sustainable product with environmental protection, kind of a good a product which has 2 or 3 ticks in terms of our local product, right? So that this can actually reduce the carbon usage. So we also have renewable energy. Hopefully, the capacity of installation of about minimum 15% of roof coverage for resident building within a development. So slowly we are getting into more renewable energy. Smart solution, we talk a lot more on this, recognizing or using a smart solution, energy dashboard, energy recovering, heat and regenerative function, occupancy sensor, and others, right? So this is the criteria for the code for environment and sustainability building. So NRB01, environmental envelope of thermal roof and transfer. So this is a little bit higher in terms of maximum permissible, which is approximately about 45 watts per meter square. So it's according to some methodology on the code of environment thermal performance of the building, right? So the building design is deemed to have satisfactory performance if it meets some basically wall to window to wall ratio and shade of the coefficient of the glasses, right? So this is basically the whole idea of having a better thermal efficiency in terms of the heat transfer. Roof also has some ranges that skylights need to be used, and then tightness and leakages. All windows and curtains should be designed in terms of the limits or in terms of the regulation of SS212 and SS654, right, to basically make sure that the design is air leak do not exceed a certain limits. So the entrance of the wall, a building, non-air conditioned space shall provide with doors with equip some maybe automatic technology, and then some of the equipment, right, should be enhanced in the vestibule and some appropriate measures for the doorway, so that with high pedestrian flow, right, there's some volume of air which I can actually make sure that the interior and external has some minimum distance between each other, and there should be some interlocks in between when they open at the same time. So this is basically to prevent some air tightness and the leakage. Yeah. So energy performance, the compliance of energy performance, which means minimal energy improvement over 50% over baseline of 2005. So these are new building that we need to think of ways to model and reduce the energy performance. The whole building approach for some energy modeling could actually be a part of it, and so we actually have something called TSE, total system efficiency, respective to the building cooling system, shall apply to kind of such building modeling. All right, air conditioning, NRB 03-2A, air or water cool building code or some of the systems. Total system efficiency for new buildings should be about 0.85, while the old building, right, or new extension can be 0.9 kilowatt per RT. So kilowatt per RT will be the chiller total efficiency. This is what we actually has also learned earlier through lessons, how to calculate kilowatt per RT, right? So air cool is basically using air as a cooling media, right? So as a cooling media reach up to about 1.0 kilowatt per RT. Okay, so there's significant difference between water cool and air cool. So learning this course, basically we know and understand what are kilowatt per RT in terms of both chiller. So the TSE refers to the combination of design and chiller plant or condenser unit for air distribution. So for some of the water cool building, right, there's codes development, like chill water temperature should be at about 6, 7, 8 to 9 to 10 degrees, and then the water cooled chiller system efficiency should be approximately 0.68 if it's old building to 0.64, and if it's a new kind of building, it should be about 0.63 for the new kind of cooling efficiency. Yeah. So yeah, so air cool also has a certain efficiency that we need to build. So for air cool, just on the unitary systems, it should be about 0.78, and for air cool plant, right, for new or existing, about 0.85. That's the efficiency, and then it kind of comply to SS553. So lighting system, there's also a code of 530 SS530. So lighting should be provided, should be 40% more energy efficient than the prescribed uh, lighting power budget, right? So mechanical systems also has some regulation that the system should have at least 10% or more energy efficient prescribed in SS553, and provision of some CO sensors, VSD to control the mechanical in the park. Measurements and verification instrumentation will be a part of the instrumentation in chilled water conditioning. Measurement of permanent measuring instruments, right, for the energy performed will be in part of the chiller plant, as you may have seen on your practical 1, right? You recorded some of the measurements, and then practical 2 you actually understand and take readings from the BMS systems. All these, right, enable you to calculate the resultant of the system efficiency. So that's how we actually try to comply the code with the energy efficiency. The code is basically SS591, and then once it's fulfilled, right, then basically we uses the BMS system to make sure that it's permanently measured so that we fulfill, right. Data logging is about 1 minute per interval and up to 3 decimal places, right. So magnetic flow meter has certain certain uncertainty, so it should be about 1%, and in situ verification should be about 2% from the factory verification. Temperature sensor will have certain measurements. Actually, it's a plus minus 0.05 degrees C for the entire measurements. Dedicated power meter should be in basically measuring the power so that we can know what is the power for various systems. Alright, instrument for VRF systems is where provision of permanent measurements, right, of the VRF system using the condensing unit. You install the instrument, you might have the capability to calculate some of the resultant efficiency. Yeah, some type conversion error within 10%. So each measurement should include some sensor and signal conditioning. So data log should be about 5 minutes, and then BMS system standalone energy monitoring should be able to capture and display and extract data. So dedicated power meter and transformers, right, current transformer should be applicable for the VRF systems. Right. Building maintenance of the cooling system performance, you need to be adequately cool the building, but it also has to design that. So several currents will be required. It is typically from the pump, cooling tower, and distribution system. Part 2 is basically on the some of the sustainability design. So effective daylights needs to be provided, and then some of the minimum spaces we need to provide the daylights, like car parks. The other piece of part 2 is also some construction, sustainable construction, where this resource of measuring efficiency measures, right, needs to be in. Some of the concrete usage index needs to be in, not more than 0.48. Yeah, so low carbon concrete is something that's very similar. It's just that it's another code. Sustainable product, environment protective declaration, EPD, is kind of a requirement that we need to do for the local body of authority. Okay, so smart building, as we really talk about what are the smart solution, better energy management in terms of thermal comfort, using some backnet or mask to have open protocol so that we can facilitate communication and integrate the other building. Yeah, so this is basically the whole idea. And then we talk about green building technology, right? So green building is basically a low carbon solution, a highly efficient building which can reduce energy consumption, either energy recovery, regenerative functions, passive displacement ventilation, where you use cool air, basically use air cooling, right, basically then to cool the room itself, and also a delicate outdoor system, right. But in thermodynamics terms, sometimes is called using the enthalpy method to calculate the energy that is required, yeah, as part of the green building technology. All right, so yeah, this is basically what we want to share a little bit on some of the requirements and codes for sustainability and green building practices. Yeah, this you might have also learned this before, but this is a very snapshot of what green building practices is all about, right?